Hi, once again, this is Nick A. Graham. I will be discussing geometric sequences in this series of videos. Definition first. A sequence is geometric if each term can be obtained from the previous one by multiplying by the same non-zero constant. A geometric sequence is also referred as a geometric progression. That means, for example, if we have 10,000 there, and the next is 1,000, and then we have 100, and then we have 10. You know already maybe that, so that if I'm going to multiply 1,000 by 10, then I will get 10,000. Okay, if its term can be obtained from the previous one by multiplying by the same non-zero constant. So if we have 10,000 multiplied by 1/10, then we have 1,000. The same is true when we have 1,000 multiplied by 1/10, then we have 100. Okay, or we can also do this. We can find the ratio R by dividing the second term and the first term. So for example, we have 1,000 divided by 10,000, then we have 1/10. And that should be equal to 2 if we divide 100 by 1,000. That is also 1/10. And this is also 1/10 if we divide 10 by 100. Before, when we have arithmetic sequences, then we have the difference, the constant. Here we have the ratio instead for geometric sequences. So if we can find a ratio, a constant ratio, then by dividing the n plus 1, the second term by the first term, then we have a geometric progression. Here's the definition. If you have u sub n is geometric if and only if u sub n plus 1 divided by u sub n is equal to r, or the ratio, the common ratio. Okay, let's see if we can find the example. For a geometric sequence with first term u sub 1 and common ratio r, the general term or nth term is u sub n is equal to u sub 1 multiplied by r raised to n minus 1. If we go back to our example here, then we have 10,000 divided by 1, and then we have 10,000 again for the second term divided by 10. For the third term, we have 10,000 once again divided by 10 raised to 2, or 100. It's better that I will put it 100. And then we have 10,000 again divided by 10 by 1,000. Then we got 10 there. Okay, this is 10,000, this is 1,000, this is 100, and this is 10. Okay, but if we simplify, we have 10,000 divided by 10 raised to 0, that is 1, and we have 10,000 divided by 10 raised to 1, and then we have 10,000 divided by 10 raised to 2, and then we have 10,000 divided by 10 raised to 3, and so on. So the general term of this now is 10,000 divided by 10 raised to n minus 1. As we can see here now, our u sub 1 is 10,000. Our r is 1/10. So if we multiply now, for our u sub n is equal to u sub 1 multiplied by r raised to n minus 1. And it should says like this. We have 10,000 multiplied by our r now is 1/10 raised to n minus 1. And as you know, in laws of exponents, this is also the same as 10,000 multiplied by 1 divided by 10 raised to n minus 1. That's why we got that one. Okay. Now we go back to this example here now that we have. Show that the sequence is geometric. How we can show that? If we can find r, which is common to all of them, we have 4 divided by 8, then we have 1/2. That should be equal to 2 divided by 4. 2 divided by 4, that should be equal to 1 divided by 2, and 1/2 divided by 1. And as you can see here, our r is equal to 1/2. That is our common ratio. Okay, find the general term. We have u sub n is equal to, the first term is 8 times 1/2, our r raised to n minus 1. You can use that as a general term, or if you want, then you have 8 divided by 2 raised to n minus 1. That's also alright. Hence, find the 12th term. Then we have u sub 12 is equal to 8 divided by 2 raised to 12 minus 1. Then we have 8 divided by 2 raised to 11. And if we're going to write 8 into base 2, then we have 2 raised to 3 divided by 2 raised to 11. Then we have 2 raised to 3 minus 11. Then we have 1 raised to 1 divided by 2 raised to 8. And 2 raised to 8 is 256. Then 1 divided by 256. Another example, show that the sequence 8, 4 times the square root of 2, and then 4 is geometric. So we have our r, we have a sub 2, 4 multiplied by the square root of 2 divided by 8. Then we have 2, we have the square root of 2 divided by 2. And then we have 4 divided by 4 square root of 2. Then we have 1 divided by square root of 2. But you can multiply both the numerator and the denominator by square root of 2. Then we have square root of 2 divided by 2. That's also the same. Next, we have 2 square root of 2 divided by 4. Then we have square root of 2 divided by 2. Then it is geometric. Why? Because we have found a common ratio. Okay, the general term now is u sub n is equal to the first term, u sub 1 multiplied by r raised to n minus 1. So our first term is 8 multiplied by r is square root of 2 divided by 2 raised to n minus 1. And we're supposed to show that this is the general term. So let's see if we can find that. If we use the law of exponent, then we have 2 raised to 3 and multiplied by 2 raised to 1/2 raised to n minus 1. That's divided by 2 raised to n minus 1. Continuing here, u sub n is equal to 2 raised to 3, and then we have multiplied by 2 raised to 1/2 multiplied by n minus 1 multiplied by, we need to take this up, then we have 2 raised to negative n minus 1, and we have 2 raised to 3 multiplied by 2 raised to n divided by 2 minus 1/2 multiplied by, I will put parentheses to that, 2 raised to negative n plus 1. And then we have 2 raised to 3 multiplied by 2 raised to n minus 2 multiplied by 2 raised to negative 1/2 multiplied by 2 raised to negative n multiplied by 2 raised to 1. And then if we're going to put together all the constants, we have 2 raised to 3 minus 1/2 plus 1. That's it. And with the n's, 2 raised to negative n plus n divided by 2. Okay, we have 3, and then we have 4, 2 raised to 4 minus 1/2, and then we have multiplied by 2 raised to negative 1/2 n. Okay, then we have, if we expand this by 2, then we have 8 minus 1 is 7. So that's it now. U sub n is equal to 2 raised to 7/2 multiplied by 2 raised to negative 1/2 n, or 2 raised to 7/2 minus 1/2 n. Then we've shown that the general term is 2 raised to 7 divided by 2 subtracted by 1/2 n. And then we're going to show now. Oh, that's it. I thought we were going to show u sub 8, something like that. No, we don't need to do that. Okay, I guess I will stop there, and in my next video I will be discussing more examples that is related to geometric progression. And once again, thank you for watching, and I hope I will see you there also in my next video. And please subscribe if you like what I am doing. Have a nice day.